Yeah, let's get started. For this assignment, I think I received 6 submissions, and they were actually among the 6. 2 of them were perfect scorers. There are Kyle and Leo. I don't think Kyle can join us now because he had a class. He may be joining us later. Leo is the other perfect scorer. Okay, so well, since Kyle is not here, Leo, you can go ahead with maybe problem number 1.
Okay.
All right, go ahead. Problem 1. So A, B, C, D is a rectangle, and I showed you A, B, and C, D. There are 4 and 3. E and F are on A, B, and C, D. So let me draw the rectangle. Here is the rectangle. Let me do this more to the scale. So A, B, C, D. Okay, and then there's a E and F. Okay, if we are folding this rectangle along EF, this is F. Okay, AB is 4, AD is 3. Okay, if we're folding along EF, B and D meet. Okay, these two meet. How long is EF? Okay, go ahead, Leo.
So for this problem, since it didn't have like anything, like it didn't really specifically say anything that had really anything to do with ENFs, other than that it's kind of like if you fold A, B, C, D across EF, then you like B and D would meet. So then that would basically be saying that if you reflect B over EF, you get D. If you reflect D over EF, you get B.
Yeah.
So basically, the correct or formal definition for a reflection would be if you reflect the point over a line, then you just like kind of like make another point. Like it would be the point on the other side of the line, such that, well, in this case, it would be you must make it so that DB is perpendicular, but EF is a perpendicular bisector of DB.
So EF is perpendicular to BD, and EF bisect BD. Okay.
So then, since it didn't have like really strict conditions, I just made F on C.
Okay, make F on C. Okay.
So then I put it on a graph.
Like this?
Yeah.
Let me do E prime and F prime. Okay.
So I made everything on a graph.
Okay.
So I made D the origin.
A graph? You mean a coordinate?
Yeah, coordinate plane.
Okay.
D is the origin.
Okay.
A is the point 0, 3.
Okay, 0, 3.
B is the point, well, C is the point 4, 0.
4, 0, okay.
B is the point 4, 3.
Okay.
And then, so first I saw that the equation of line DB would be y is equal to 4/3 x, I think. I mean 3/4 x. Wait, 3/4 x.
Okay. So make this x, this is y. Okay.
So then I tried to find the line of equation for line EC.
EC, okay, this
or
line.
EF is the same.
Okay.
EC or EF is. So then I found that
I will do E prime C.
Yeah. So perpendicular slope, if 2 lines are perpendicular, that means their slopes are negative reciprocals of each other. So I made the point slope form, which is basically a standard form or y-intercept. Okay, so then I
point slope form. Okay, so here is x what?
Plus 0. X minus 4.
Okay. So that's y equals
negative 4/3 x plus 16/3.
Okay.
And then I think I did something like, so, oh yeah, then I try to find E prime.
Okay. Find
so
E prime.
it would be when y would be equal to 3.
Okay, y equal to 3. Then 3 equals -4/3 x plus 16/3.
We
Okay.
multiplied everything by 3.
Okay.
So then I subtracted 16.
Okay.
So then x is equal to 7/4.
Okay. So this is what?
7/4 3.
Okay.
So then it would just be a right triangle.
Which one?
EBC.
Okay. EBC. Okay.
So line segment EB.
Oh, this is E prime. Okay.
Line segment E prime B has length of 4 minus 7/4.
Okay. 4 minus 7/4. That's what?
Which is equal to 9/4.
Okay.
And then line segment BC has length 3.
Okay.
So it's using Pythagorean theorem. You get not square root E prime C is equal to square root of 81/16 plus 9.
Okay.
Which is equal to square root of 81 plus 144, I think, over 16, which is equal to 15/4, or square root of 255/16.
To what?
225/16, which is equal to 15/4.
All right. So this is 3.75. Okay, good. This is good. All right. Any other solutions? This is good. Basically, Leo used analytic geometry to solve this problem. Any other solutions that doesn't need this advanced math? William, you want to have a try?
No, I think I got it wrong.
Okay, I'll give you guys a hint. Okay, here's a rectangle. This is 3, this is 4. As Leo said, A, B, C, D. Leo said, oh no, A, B, C, D. Okay, EF bisect BD and perpendicular to BD. Okay, so this is E, this is F. There are different ways to solve this problem.
Oh, I think I might know.
Okay.
So for this, you first need to just kind of connect FB.
FB? Really? I doubt it. Okay, yeah, go ahead. Let's try it. And then what? FB, F should be somewhere here.
Yeah, and then connect ED.
ED, okay.
And then name the point where EF and BD intersect each other, maybe G.
Okay.
So then you can establish, I think, congruence.
Yep. Which one is congruent to what?
EDG is congruent to BFD.
Okay.
And EGB is congruent to DGF.
Yeah. What else?
And
I'll give you a hint, all right? So, I mean, this one, you can solve it this way. Let's look at an even easier way. Okay, so BD. You know 3, you know 4. What else do you know?
BD is 5.
Okay, BD is 5, right? And then here's EF. EF. EF is perpendicular to BD. What do you see now? Let's say this is G.
Wait, I know.
Okay.
So you can, well, you do have to establish congruence, EGB, DDF.
You don't need that.
Well, GB
Uh-huh.
should be 2.5.
Okay, GB is 2.5. Okay, then what?
So then, Pythagorean theorem.
Okay.
So it's...
Why is Pythagorean theorem? Where do you need a Pythagorean theorem? You don't need it yet, I guess.
Wait. Why don't you just find EG and you multiply by 2?
Yeah. Okay, yeah, in order to know EF, you need EG. So once you multiply 2, EG, EG times 2, that's EF. Okay, so how do you find out EG?
Pythagorean theorem.
How do you do that Pythagorean theorem? Because you don't know BE, right?
Oh yeah, done. Oh yeah, BE isn't 1.
Okay. Anyone else? Or you want to keep trying?
I'll think about it.
What do you know about this?
Oh, similarity.
Okay.
So they both share angle B.
Okay, they share. Which angle can use B? There are many B's.
Okay. Well,
which angle?
Angle EBG.
EBG, right? That equals angle DBA, right?
Yeah, and they both have a right angle.
Okay.
So you can establish similarity.
Okay.
And then BG is 2.5.
Okay, BG is 2.5.
And the corresponding side on triangle ADB is AD, which is 4.
Okay.
So then the ratio of each side beat the smaller triangle to the larger one is 2.5 over 4 or 5 over 8. So then it would just be EG's corresponding angle is AD. So it's 5/8 times 3.
Okay. So EG equals
15/8.
15 over 8. No.
What?
Yeah, 15 over 8.
But isn't that like less than 1? Isn't that 15 over 4?
You have EG 4? Now.
Oh yeah, multiplied by 2.
Okay.
And then you get 15 over 4.
Yeah, is 15 over 4, right? Okay.
Yeah.
Good. Let's see. Who's here? William and Kenny. You got it? If you got it, give me a thumb up.
I got it.
Good. All right, Kenny. Good. Good. All right. Next problem. Next problem is actually a little more difficult. Okay. But once you know how to solve it, it's easy. Let me use this. I want to copy that equation. Okay. Oh, well, it couldn't copy the anyway. So let me write it down. So 2x cubed plus 5x squared minus 19x minus 42 is 0. Okay. Any one of you want to try this? So A, B, C are 3 roots. Are roots. What is a plus b plus c squared? Anyone want to try this? Nobody?
I'm trying to just do trial and error.
Oh, you did try and error. How did you do try and error?
Well, for this, I first found that if you factor it out, then it would be kind of like in the form of like dx plus e.
Dx plus e, okay.
Times fx plus g.
Okay.
Times hx plus I.
Plus I, okay. Equals 0.
Yeah.
Okay.
So 2 is equal to d times f times h.
Okay. D times f times h is 2, okay.
And then negative 42 is equal to e times g times I.
Okay.
And then a would be negative e over, if a is the root for dx plus e, b is the root for, if a was the root, if dx plus e is equal to 0, b is the root if f of x, fx plus g is equal to 0, and c is that.
Okay.
Then a is equal to negative e over d, b negative d over f.
So here I have a question. Why do you have so many numbers? Why do you have dx, fx, hx? Why don't you make them x minus a times x minus b times x minus c equals 0?
Well, the coefficients may be greater, may not equal 1. And
which coefficient may not equal to 1?
The coefficient on the x term.
On the which x? Oh, here? So you mean they're okay? So why do why do they matter? Why do they matter? Why do you have to, what if this coefficient is not 1? Let's say, what if here is 2x minus 2a times x minus b times x minus c? I mean, you like to use other numbers. So let me see, let's say 2x minus d.
Well, you can divide everything by 2.
Yeah. So
but there is a possibility that like one of the coefficients is 4, the other is like 1/2 or something.
Okay, so let's say here is 4x minus d. Let me scratch this. And this is 1/2 x minus e times x minus c equal to 0. So what's the problem with this?
Well, you can't really do a lot of stuff about it.
What can I not do, right? So if I just look, I divide this by 4, I multiply this by 2. I will just make them all x, x, x.
That's also the way.
Right? So for any coefficients here, for all these d and f and h, we can make them 1. Right?
Yeah.
Okay, so now keep going. So now let's say we can do this, do them this way. We can do this x minus a, x minus b, x minus c. Then what?
So then yeah, it's just ABC.
Okay.
So
the original equation is this.
Oh, okay. Yeah. So now you don't have to do trial and error.
Okay.
So now basically it'll just be x cubed plus 5 over 2x squared.
Cube plus 5 over 2x squared.
Minus 19 over 2x.
Over 2x.
Minus 42 is equal to 0.
Minus
29. Okay, so now you can, so on the 5 over 2x squared, how you get it would be just add all of the ways. So how you get 5 over 2x squared is just negative a times x squared, or it's just negative x squared times a plus b plus c.
Negative x squared times a plus b plus c. Why is that?
Well, for this, it's really just, you can kind of think of each small term just being kind of like the sum of every kind of like.
I don't need kind of like. Okay, I want a solid answer. Why is this? Where did you get this?
Well, for the 5 over 2x squared from.
No, I mean, why this x over 2, x squared term, the coefficient is negative a plus b plus c. Why is that?
Well, how you get it would be you first, you can go back to your x minus a, x minus b.
Okay, I'm going back to this. Let me rewrite it. X minus a times x minus b times x minus c equal to 0, okay?
So you basically just, to get the product, you must multiply every like 3. Like,
let's just multiply them out.
Yeah, multiply.
Okay.
Then you first multiply x by x to get the x cubed terms. And then to get the x squared terms, you do x by x times negative c.
X by x times negative c, x negative c.
And then x negative b
x. Oh, x negative b x.
And then negative a x x.
Negative a x x. Okay, so that's at minus a plus b plus c x squared. Okay, and then what?
And then you just do, next would be the x terms.
Okay, x terms.
Which would just be x times negative b times c.
X times negative b times c.
Times negative c.
Times negative c. Okay, that's bc.
And then negative a times x times negative c.
Negative a times x times negative c. That's ac.
And then negative a times negative b times x.
Negative a negative b x. That's ab. So that's what? What's the x?
ab plus ac plus bc times x.
Okay, very good.
And then it's just minus abc.
Minus abc. All right, great. So now we have this. Then what?
So then you kind of like.
We don't need kind of like. Okay, I need a solid answer, not kind of like.
Well, then you can just match each term.
Oh, the other one is x cubed plus 2x squared minus 19 over 2x minus 21 is 0. Okay.
So you can, what you're trying to find is a plus b plus c. And you can find it in the negative a plus b plus c x squared.
It's right here.
And the corresponding one and the actual answer is 5 over 2 x squared.
Okay.
So then a plus b plus c is equal to negative 5 over 2.
Okay.
So it's negative 5 over 2 squared is 25 over 4.
Okay. A plus b plus c squared is 25 over 4. Very good. Okay. Clear? Any questions?
Dr. Hong, I think I might have an easier solution, but it's pretty similar, I guess.
Oh, is that Kyle?
Yes.
Oh, great. So, when you were not here, Leo took the privilege as the spotlight student to talk about these problems. So now it's your turn. Go ahead.
Okay, so what I just did is I made the equation 2 times x minus a times x over b minus b times x minus c.
Oh, okay. So because you saw the 2 over there, so you make 2 times x minus a, x minus b, x minus c equal to 0. 0. Okay.
So you see that the corresponding so there's plus 5x squared. So you see that 2 times negative. Well, first the inside is a plus b plus c, as Leo said. Same logic. Times x squared.
Okay.
Equals 5 over equals 5.
Okay.
So
And then the rest is the same, right? So you can calculate a plus b plus c, right?
And you square it.
Very good. Okay. Yeah. So this is, typically when we solve a quadratic equation, we can basically, if this were a quadratic equation, it could be x squared plus bx plus c. I mean, I'm just, this bc is, they're different from the abc over there. We don't really care if there is an a or not, because if there is an a, we can always move a, divide the equation by a from both sides of, divide both sides of the equation by a, then we can always make the coefficient for the highest order term is 1, right? So we don't really care about it. So the same idea here, Kyle did 2 times x minus a times x minus b times x minus c. And then what Leo did, I think when he solved this problem originally, he did trial and error. He figured out the roots, right? Is that what you did?
Well, I only figured out 2. Therefore, number 1.
Okay, so you figure out the 2 roots, 2 integer roots, and then early on you talk about it. We can basically use use this write out, multiply this x minus a, x minus b, x minus c to come up with another equation that match the original one, right?
At first I did find that, but just after that I kind of thought about the 1/2 and then
you were confused about the highest order term, the 2 here, right? Okay, good. So later on, when you study competition math, you will learn a formula, a famous formula. You will encounter that later on. But Vieta's formula. But for now, I'd like you to understand the basics. So if you can multiply out these 3 terms, then you're fine. Okay. Okay, Kyle, you want to talk about the last problem?
Yes, I can.
So the last one is 5 squares in a circle. Okay. So I'm putting 5 identical squares in a circle of radius 10. And I said these squares do not overlap each other. And what is, come on, this is not a circle. Let's do this. Okay. A little more like a circle. Okay, Kyle, go ahead. Ask what's the largest side length for the square?
Yeah, so the first thought that came to mind is using a plus sign for the squares.
Using what?
A plus sign.
Like this?
Yes.
Okay. Okay.
And I figured that must be the largest.
How do you know this is the largest one?
So first, usually you just put a large square in the circle and you'd split it into 4. But you can't do that with a square in 5. You can't split a square into 5 other squares.
Okay. So why not something like this? Why not 1, 2, 3, 4, 5, and then a square like this? Why not like this?
Because then the radius would be
And by the way, Kyle, I'll let you finish. So do your calculation. We'll leave the proof later on. So complete this. So
I'll just make the side lengths of the square x.
Okay, x.
So the radius is 10. You can draw it from the center to one of the corners.
Okay, this is 10.
So you just use the Pythagorean theorem.
Okay.
So see that 3x over 2 is one side of it, and then the other side is.
Want to do this?
Yeah.
Okay, so this side is 3x over 2, okay?
And the other side is x over 2.
X over 2.
So 9x over 4, x squared.
X squared over 4.
Plus x squared over 4 equals 10x squared over 4.
Equal to what? Oh yeah, 10x squared. I mean, they equal to 10 squared, right?
Yeah.
And then we solve this, okay? So you solve it, x squared equals what?
X squared equals, wait a second. Yeah.
Right, so x
Equals square root of 40, or 2 times the square root of 10.
All right, so that's the correct answer. Now let's go to the proof. How do we know this is the large, this is the way to place these 5 squares?
Well, symmetric, I guess. Kind of.
Symmetric, okay.
No, not really.
I mean, if I want you to put 3 squares, if you were putting 3 squares in an X, in a circle, would you put it this way?
No.
Right, this is symmetric.
Well,
how do we know this is the largest?
Well, for this one, there isn't any room to put like any more of those identical squares, and it's also, and in the same structure, it's also impossible to make this even bigger.
Yeah, why? Why is that? You are saying the things I want you to prove. Why is that? Why is that?
Wow.
All right, I'll give you guys, because this is the last problem. Think about it. But think about this. All right, so in order for these squares to be in the circle, so that means when you connect any vertex of this shape, connect any 2 vertices, the connection, okay, when you connect these 2, for example, okay, they must be less than or equal to the diameter of the circle, right? So let's say if you connect any 2 points among these 5 square shape, if the line segment for any of these line segments is longer than the diameter, that means the circle does not cover this shape, right? So when you place 5 squares here, 1, 2, 3, well, you have to have 3 somewhere, right? And the other 2, you either put them like this or like a cross, or you do it like this, right? So the smallest distance, the shortest distance, that will involve 3 side lengths as one side of a right triangle and the other one as the other side of the right triangle. So this is actually the smallest diameter you can get, right? I mean, think about it. No matter how you move, let's say if you move connecting these 2, okay, let's say if this was a diameter and you draw a circle, right? So think about the lines, how long these line segments are, okay? So when you draw a circle, find out the diameter. This will be the diameter, okay? And if you look at this will be 2, this is 2.5, 2.5, this is 2, okay? 2.5 square plus 2 square, this is actually greater than square root of this, is actually greater than square root of 10. Well, this one is square root of 10. This side is longer than this one. So this is square root of 10. This is square root of 10.25. Okay.
Well, you also want to make sure that, you also want to make the side length as large as possible. So you kind of want to make the amount of the side length that make up the diameter as small as possible. So then you can basically just start trying from like 2 squares and go down to like to go across the diameter. And 2 squares doesn't work, so.
Yeah, I mean, for this problem, there are really 2 shapes to consider. You know, this shape require a bigger circle. Okay, again, if we consider each side length is 1, you know, the diameter to cover this shape will be at least square root of 10.25. Okay. Well, you can play with it. You know, think about when you have a square, how do you place 3? I mean, when you have a circle, how do you place 3 squares to make the side length of these squares the biggest? Okay, that's tougher. Okay, so that's not for today. I may assign it next time. Okay. Any questions about the problems we discussed today?
It was kind of fun.
Well, 40 minutes. That's okay. Ooh. Oh, is this dead? Okay. If no, I will see you hopefully in a few weeks. Okay, so try to work on as many problems as you can for this CMM problems, right? So we have high school level, middle school level, elementary school level. You know, try to work on those problems. For you guys, you probably don't need a beginner level. Okay, work on those problems and keep your brain running. Okay, stay away from video games. Okay.
So there weren't that many people that did this.
Yeah, this one is too tough, I guess.
Wait, Dr. Hong?
Yeah?
On the submission thing, I submitted the first one as 15/4 and the second one as 10/2, but it only shows that 2 people got them both right.
Who's that, Kenny?
Yeah.
In your submission, the first one is 15/4. The second one is empty.
Well, I typed in 10√2.
That's the third one.
Well, no, yeah, the third one.
But the second one is empty.
Yeah, I left the second one empty.
Yeah, so I said I was saying.
But you said that only 2 people got those right.
Yeah, because the third one is now 10 times square root of 2. The
no,
third
I was
one times square root of 10.
Oh wait, I said 10 times square root of 2. I meant 2 times square root of 10.
Your answer was this: 10. You put a star, which is multiplication times SQRT2. This is what you wrote. But the answer is 2 times square root of 10, or 2 times SQRT10. Okay?
Yeah, but the first problem still only says 2 people got that right.
The first problem had 1, 2, 3 people got it right.
In the email it says 2.
Oh, okay. So my bad. There were 3. Yeah.
Okay. Thanks.
Okay.
How many submissions were there?
I think this time we have 6. 1, 2, 3. Yeah, 6.
Yeah, what about the other people? Where did they go?
No, they just didn't have time to attend it. They can watch YouTube. Okay. All right, guys. I will see you in a few weeks. Okay.
Bye.
Bye.